Okay, I have a couple announcements from the Stir Trek board. First of all, if you bought a +1 ticket, it's at registration. If you haven't picked it up yet, please do so. And secondly, we're being asked that as you exit the theater, please exit that side so that people can come in through that side and we don't have a mad crush of people all trying to trample each other. Okay, thanks.
Okay. You guys in the back hear me? Thumbs up? Awesome. All right, so good morning, everyone. Welcome to Modular JavaScript, Browserify versus RequireJS. If that's not what you're here for, we already locked the doors, so you're in for the long haul. Take a nap for an hour till lunch. My name is Jeff Valore. You can follow me on Twitter if you want. I don't tweet a whole ton, but there's some stuff out there. I've been programming professionally for about 15, 16 years now. Over the last 3 years, focused primarily on front-end JavaScript, lots of large-scale single-page apps and things like that. All JavaScript, CSS, HTML, good times. That wasn't always the case, though. I did a lot of .NET and Java before that, and for about a decade, I actually completely hated JavaScript. Thought it was a terrible language, just a giant ball of unstructured goo. About 3 years ago, though, I came to the revelation that I didn't hate JavaScript, the language. I really just hated other people's JavaScript. And that was largely because when you would inherit somebody else's JavaScript, you would get that. It was just one JavaScript file that was 10,000 lines long, all properties and functions dropped into global scope, have a good time, have fun not trying to collide with other functions already in global scope or trounce over properties. Or you'd get the other variant, which was a document on ready or on load handler, and then a single callback function that was 10,000 lines long, and just all nested callback functions, anonymous inline functions, pretty much eliminating code reusability and things just copy-pasted everywhere in Ajax success handlers and whatnot. And so these are the reasons that I hated JavaScript for a long time. But I came to realize that it's not really a JavaScript language problem. It's sort of in the way that we learn JavaScript. If you compare it to other languages, we learn structure right off the bat. You learn C# or Java, you learn about classes. Classes go in a file. There's multiple files. You can put things in subfolders and use namespaces to kind of clean them up. And then there's a very defined build step where you kind of go from development time and multiple files to a build, and then you deploy a single executable or jar file or war file or whatever you're building. That was really never the case with JavaScript, and so how many carried over from the last talk? Some of you? So right at the end, he was talking about using grunt as a build process and kind of doing a build time JavaScript step where you can bundle up and minify your JavaScript and deploy a single file, because that's really what you want for performance, which is why in the olden days, people would just code everything into one giant JS file, because we're going for performance. We don't want to make 22 server requests. We can just make one. So at development time, we'll just build one giant JS file, and now you can't maintain it. So building this build process into JavaScript has been kind of the latest evolution that the JavaScript community has gone through with tools like Grunt and Gulp that were mentioned previously. So what we're going to look at today is some module loading frameworks. They're kind of a dime a dozen at the moment. There's at least 4 I can think of, and I'm sure there's others out there. We're going to look at Browserify and RequireJS. The point of a module loading framework is to give you that ability to have multiple JavaScript files at development time, and then essentially bundle them into a single JavaScript file at runtime. In the olden days, people kind of tried to build their own or roll their own kind of in the middle here. So I'm going to look at one example of that quickly. And I'm not associated with these guys at all, but I happen to find their code as a good example. Pixie.js is a WebGL rendering framework for JavaScript. I pulled their code off GitHub, so let's take a look at what they do. All right, hopefully you guys can see the tree view on the left. I hope that's big enough. It took me like an hour to figure out how to bump that font up in Sublime, so I'm sorry if it looks weird. So they have a source folder with Pixie in it, and then you'll see that their code is actually organized pretty nicely. There's a pixie.js down at the bottom. There's folders for filters, geometry, loaders, primitives, renderers. And if you look at loaders, there's all kinds of different loaders here. That looks like an ideal situation, right? That's basically what we do in C# or Java or whatever other languages you're using. We build out multiple files in multiple folders. So let's take a look at asset loader and see how it works. So what they're doing here is a technique commonly called namespacing. If you've gone to any other like clean JavaScript talks, they will talk about not polluting global scope, and doing that often by making a namespace of objects. Basically, they have a Pixie object on the left here. That'll be the single object exposed in global scope, and then they're adding a function to it called asset loader. Okay, cool, that kind of keeps it from polluting global scope and kind of keeps this file down to a single responsibility for asset loading. So asset loader probably uses some other things in Pixie. Oh, look, here we have image loader used a bunch, JSON loader, Atlas loader. It uses some other things down here. But it basically has dependencies on other files in this project. And so that's where this namespacing technique gets a little bit tricky. So fortunately, these guys have a grunt build process around this that we can test. Yes, they unit tested their JavaScript. Good job, Pixie guys. And they all pass, which is also pretty cool. So let's look at their build process for turning these multiple JavaScripts. They actually deploy a single file just called pixie.js if you were to actually use it. You don't have to go request all hundreds of these files. So they use grunt, so there's a grunt file here. And right off the bat, you start to see something a little fishy. They have every single file listed here in an array. And somewhere down here, there's a concat task where their build process is kind of homegrown in that they just take every single JavaScript file and concatenate them together into pixie.js, and now we have our one file to ship. Okay, so let's find asset loader in here, which we were just looking at. Where are you? There you are, line 68. So remember that asset loader depended on some things. So if we move asset loader, or maybe we're making a new file one day and we wanted to come add it to this list, where in this list do you think it has to go? Let's move asset loader maybe up here to the top, because that looks like a fun spot. Never mind my indentation. If I rerun my grunt test, oops, it blows up now because I reordered a file, and now its dependencies aren't in existence on that global Pixie namespace object yet. So this looks really cool from the development perspective of having multiple files, but we've kind of killed any dependency resolution that we have in that there really isn't any other than a developer manually putting these things in the right order. So not quite ideal. So we're going to try to solve these problems with modules. So our module loaders are going to define a module as basically a file that encapsulates a single responsibility in JavaScript. If we're looking at it from the solid principles perspective, we're looking to solve the S and the D. Single responsibility, put all the common functionality for a single responsibility into a single module, promotes good code reuse, should be a small testable chunk of code. And dependency inversion principle, this one's a little bit fuzzy in JavaScript, specifically with both these frameworks, especially Browserify. But really, we want to try to do less work trying to resolve our dependencies, and we especially don't want to have to, in our build process, say that this file comes before this file because it depends on the one before it. We want something else to worry about the ordering and how dependencies load and are linked together. Okay? So we're going to look at two module loaders specifically, Browserify and RequireJS. But before we do that, they actually share a common lineage, which is kind of interesting about these two module loaders. Back in, I believe it was the mid-90s. If somebody actually knows, they can correct me. I think it was somewhere around 96. The Common JS group formed. And these guys were kind of interested in taming the wild west of JavaScript and coming up with a good set of standard practices for JavaScript. And they were really kind of focused around server-side JavaScript, what would basically become what Node.js is. So one of their specifications that they came up with was a module pattern and how module loading would work. If you're anything like me, you're kind of wondering if that's a ripoff of the Contra logo, and it's actually not. The C is just very similar. So the CommonJS guys came up with the module specification, and this is a copy-paste straight off of their website of how they explain their modules. So these are actually 3 files. I hope you can see the gray comments, and they're not too, actually, that's not very good contrast from where I am. But I tried to put comments of what the file names are. So there's one at the top here. Oops, didn't need to actually tap. There's one at the top named math.js. So CommonJS specifies a module goes in a single file, and that module's name is its file name. So this top block would define the math module. They also specify that there's kind of a hanging variable out here named exports, where the module is actually defined. So by default, this is just an empty object. It's just a hash. And we can add things into it to export them to other modules, since modules will be interdependent on each other. So we add a property to the exports that is named add in this case, because we're making an add function in our math module. And we just assign it a function. The contents of that function aren't really relevant. Then in the middle block, we have a file named increment.js. And that is a second module named increment, and it needs to load the math module. It has a dependency upon it. So what the CommonJS group specified was a kind of hanging function here that's just openly available called require. And the require function takes in a parameter that is a string that is the name of a module that you want to load. So it gets the math module, which would load the JS file from up above. And then it can call .add, which is the function that we assigned up in the first module. It then re-adds an increment function in its own exports. So it basically brings in another module, sets up its own exports that it's going to expose to other modules, and passes that back off to the module loading system. And then at the bottom, we have a file called program.js. This is going to be basically the main entry point. The program.js is not specified. It doesn't matter what the file name is. But in their example, it's named program.js. So it requires in increment and then calls the function. So when the module loader would look at this, it would actually start processing at program.js. It would see that require increment is called, and then it would go load increment.js and try to execute that JavaScript, see that there's a require call to math, go and load math.js and start executing that JavaScript. And then when there's no more requires, kind of the dependency chain has been fulfilled, and then it all comes back down to program.js. Okay, I hope that makes sense. I know it's a lot to take in at once. So the CommonJS group came up with that specification. And then, like I said, they were kind of focused around server-side JavaScript. So when Node.js came around, they looked at this and said, hey, cool, somebody already figured out how to implement modules. We don't want just one giant JS file. We want to load separate modules. So how many people have done Node.js development? Surprising. Good. About half the room-ish. This is going to look really familiar to you guys then. So Node.js implemented the CommonJS spec as their module loader. They've since publicly stated that they're not really going to adhere to CommonJS anymore, but the whole module loader in Node.js was based off that specification to begin with. And so it basically functions exactly the same. That works awesome for server-side JavaScript, where when you call a require function, it can just synchronously go hit the file system, pluck up a JS file, stick it into Node.js. That's great. What about in the browser? We can't really do that exactly. So the Browserify module loader is actually a web-centric implementation of Node.js's module loader, which is an implementation of the CommonJS spec, or at least was originally. So if you're doing Node.js development, Browserify is going to look super familiar. They basically just take everything that Node.js's module loader does, re-implemented it as a Node package, so it actually runs as a build step in Node.js, and does the exact same thing, takes in the exact same CommonJS style modules, and builds up one deployable JavaScript file. So we're going to do 2 quick sample applications. I'm going to try to live code these. Hopefully they go well and I remember everything. We're going to basically build this module tree. We're going to make the ubiquitous calculator sample. It's going to be its own module. It's going to import a multiplication and an addition operator modules, so we're going to separate those out. And since multiplication is really just a fancy form of addition, we're going to do multiplication using the addition module. So there's kind of an inner working dependency tree there. So we'll do it in Browserify first, because quite frankly, it's easier than RequireJS. Browserify.org has the docs and stuff like that for Browserify. Really, you can just npm install it globally, which is what the -g is for. So that'll actually add a Browserify command to your runtime. So you can do a Browserify -- version that kind of line wraps at a really goofy spot. It apparently does not realize that I resized that window. But I have it installed. I'm not going to npm install it here because there's no internet connection. But that's the command that I ran to get that there. If you're looking for docs in Browserify on specifically how it's resolving the paths to modules and what files to pluck off the file system, you really want to look at Node.js's documentation. It's much better laid out than Browserify. But Browserify is just a re-implementation of the Node.js module loader, so the docs that apply to Node.js's module loading system really apply to Browserify as well. All right. So this is where I'm going to do my samples. I have two high-level directories, Browserify and Require, because I'm just going to do them in the same Sublime window. Just ignore the Require folder for now. I also have a dist folder. So the thing we're going to build is just going to be a quick web page where we have a couple input boxes, a left and a right input box. We'll type in two numbers, click a button that says multiply. We're going to grab a file called calculator.js, which is the single deployable JavaScript file that I'm going to build in the end. And it'll display the result in this little result span. Note that my script is being loaded at the bottom of this document. If I tried to load this particular script in the head, it would not work because these DOM elements would not exist yet. I'm going to be using jQuery to grab them. But as was mentioned in the previous talk, the bottom of the page is kind of the best place to put scripts nowadays anyway. So let's start in our source folder. I'm going to start with the addition module because it's pretty much the easiest thing. I'm going to put my operators in a subfolder. So I'm going to make an operators folder under source, make a new file. We'll call it addition, which will be the name of our module. I'm going to leave these up here as a comment so you know where we are because the tabs are tiny. And so this will follow the common JS syntax that we just saw. So I'm going to put a use strict up here because it's just the right thing to do. And then I'm going to export.add equals, define a function here that will do my addition. It's going to just take in two things and return the sum. OK, super simple. Pretty much as easy as a module is going to get. It has no other dependencies, so it doesn't require anything in with that special require function. It just adds a function to its exports. OK? Let's make a second operator for multiplication. And if I type something obviously wrong or stupid, just yell at me, please. That's actually lowercase. This is a funny font, apparently, or it looks weird when it's big. That's the one you were asking about, right? Excellent. Yeah, and this L looks like totally a normal L. Go figure. Yeah. All right, multiplication. So multiplication, we're going to use the addition module to do it. So we need to bring in the addition module. So I'll just require it in with the require function, which will set up that dependency. And then in here, we need to specify the module name. So in Node.js and hence Browserify, when you want to load a module that is relative to your code already, so it's in your code structure, it has to be a relative path. So it has to start with a dot in some form, either .. or .. So I'll do a / addition. without the .js file extension, and that will tell it to load the addition.js file in this current directory. And so what this addition variable here will be is exactly this exports object. So it will have an add function that is assigned to it. This is a terribly stupid example, I know, but just roll with it. OK, so it just loops for as many times as the left parameter, adds it to the running total, or adds the right side thing, total number of times, returns the sum, right? So it's just a module, it has a dependency. That's all pretty cool. I pass in total and then add right to it, so it actually is the correct running total that way. I could have just plus equaled right, and it would have done the exact same thing cleaner, but I just wanted to use a different module. So let's save both of those. So this is one of the weird things about the common JS syntax that I don't particularly like. This file makes it look like, if you just plugged this multiplication.js file into your browser in a script tag, where does addition live? Global. And export seems like it's just a cool thing hanging out in global scope too, right? And require also looks like it's just hanging out in global scope. That's actually not true at all. What happens is this entire thing gets wrapped in a function that looks like this. At runtime, after this is browserified, this is what actually goes to the web browser. So that it just wraps it up in a function. So all the stuff in your scope here is actually scoped to the function. So if you've ever seen the revealing module pattern in JavaScript, this basically follows it. We can have essentially private properties here that are now scoped to our function. So nothing outside of this module can ever get to this addition variable unless we added it to our exports explicitly. Same thing with any other functions we define in here. They become private to this module. So it has its own scope just inside the module. This is also why the use strict works right here. It's actually the first line inside of a function. So it's a bit of a lie, the way that it visually looks. You just kind of have to know that these things are getting wrapped in a function scope. And so not totally intuitive or spelled out for the new user, but once you know it, the syntax is kind of nice and clean because there's no like wrapper stuff, there's no ceremony, there's just code. All right, so let's make our main file here. I'm just going to call it calc.js. And calc.js is going to grab in addition. Again, we need to specify a relative path here. So this is, my calc file is in the source directory, and addition is in operators. And again, we don't put the .js file extension. And I'm also going to use jQuery, as I mentioned earlier. So I'm going to actually not use jQuery out of global scope, as you're probably used to doing, because that would mean inserting another script tag. So I'm actually going to add a require statement for jQuery. And I'll get to exactly what that means in a moment. But for now, let's just say that it's there. And I'm assigning it $2 signs, so we can just use it like usual. So I'm going to grab my left and right parameters out of my input boxes. This is probably going to be a little bit ugly, but have a button named Go. So we'll just add a click handler for that. Okay. Does anyone see anything horribly wrong there? I think I've typed that all right.
Do you actually need to require the addition?
I don't. Thank you for pointing that out. I don't actually need to require addition here. So if I did not have addition loaded and I added multiplication, the module loader in Browserify would go load multiplication and then see that it in turn needs addition, so that module chain would get fulfilled either way. The reason I put addition here is because of another thing that I'm not super fond of in this module loader, which is that require is basically non-deterministic. I'm loading the addition module here and passing /operator/addition, and I'm loading it here, but it's just /addition from here, just because these files are in two separate folders. So I don't particularly like that the module you're writing needs to know its path relative to the modules you want. It's kind of quirky like that. If you start refactoring your code and you move things into different folders, things could suddenly start to break. Or if you had two addition files, one in source, one under operators, and you moved multiplication back to the source folder, it would still just magically work, but pull in the wrong module. So I don't particularly like that about Browserify and Node.js, and that's actually different in RequireJS when we get to that. So thank you for pointing that out. So Browserify, that should be our modules. That's our three modules that I wanted to define. So Browserify is a command line thing. We can now Browserify our code. Since this would be a build time step, you could integrate this with Grunt or Gulp or whatever else you do, or just run it as a command in a batch file, I don't know. So we would pass in the file that we want to start processing from. So that's going to be source/calc. And we can just pipe the output to where we want it to go, which in this case is going to be the dest. That should actually be dist. All right, so this is going to tell Browserify to go grab the calc file, process its dependency chain. What it's actually going to do is look at the abstract syntax tree for the JavaScript, find all the calls to require, and go and load those modules. And then it'll dump the bundled single file out to calculator. And it gives no output, but that's a good thing in this case. There were no errors. So in here, in my dist folder, we now have a calculator.js, and we can see what this is. Oh, you know what? I never came back to how it resolved jQuery. Let's look at that really quick. Sorry. Where'd you go, calc? So I required jQuery here. It was not relative to anything because I didn't put a dot there. What this does is follows what Node.js would do, and it actually looks for other npm installed packages. So I happen to have run npm install jQuery before getting here, since there was no internet. And so there's a node modules folder here that actually has jQuery in it, which matches this package name, or this module name that we're looking for. So what Browserify does is it says jQuery, it's not a relative path, cool. Let's look at the npm, or the npm installed modules in the node modules directory. I see you have a jQuery. Cool. There's a lot of stuff in here. So the way it figures out what JS file to get is that it pulls up its package.json and finds the main property here. And this maps to dist/jQuery.js. So that's how it ends up resolving a module if you don't make it a relative path. It should be an npm installed package that way. All right. So in our built calculator.js, we can see what we have. We have the entirety of jQuery up here at the top, and for most of the file. And down at the bottom, we can see our multiplication.js module. And note, I said before that it gets wrapped in a function, and there is that function that it wrapped it up in. So that's multiplication. Here's my addition module. Here's my calc module. So now we have one JS file. Note that this isn't minified, but it also supports minification. There's a command line parameter you put on there, I believe, and it'll minify it. It can also do source maps, because debugging gets difficult when things are bundled into one JS file. Both Browserify and RequireJS support building source maps for these things to ease debugging. So this is what we get and we would deploy to the customer, is this calculator.js file. So let's run this guy. I'll reload this page once and unset my breakpoint and not click that. Okay, so this hopefully works, and it doesn't. Cool, so I've done something wrong in my code, but the module's still loaded and there were no console errors. So I'm just gonna roll with it and not go back and find my code because time. Yeah, I probably did do that. But that's okay. I'm not going to go back and fix it. The important thing is that the code's in here. If you look at the network tab, there's an index.html got loaded. It then loaded one file, calculator.js, and that had all of our JavaScript in it. Okay? So that's really the point of the whole module loader. At development time, we got to edit 3 files and bundle them together in a build step and deploy one file to the customer. Yes, and that's where source maps would come in. You can make it so that if you opened the sources for calculator.js, they would not be this giant ball of everything bundled together, but it would map back to the original files that it came from with correct line numbers and everything, and you could set breakpoints and all that. And that's kind of a feature built into all the browsers nowadays. So if you want to know more about that, look up source maps. And so that's kind of the Browserify demo. That's basically how it works. It's a build time thing only. There's nothing that really happens in the browser once it's loaded. You just deploy that one JavaScript file. Everything's put in there in the correct load order. It sets up those require functions so that when you require something, it goes and pulls it out because it's already in the browser in that giant bundled file. So these are the general rules around module loading. If it starts with a dot, it's loaded relative. If it's not a dot, it looks in npm installed modules. There's a whole plugin framework for both Browserify and RequireJS that can change those rules. So if you're using like Valore instead, there is a Valore plugin that you can put into Browserify that'll make it check the Valore packages folder instead of npm modules or node modules. So there's a rich plugin architecture for both of these module loaders. All right, so back to the common lineage of the two as we transition over to RequireJS. So back when CommonJS was still being worked on initially, they were really focusing more on the server-side stuff. And this require function, if you remember the syntax, takes in a module name and returns that module. So somebody in the CommonJS group back then said, hey, wait a minute, that doesn't work in the browser. If this is running in a browser and we need to go load a module, a JS file, we need to make a request to the server, which is going to be asynchronous. So what would my require function return? It would have to return like a promise or take in a callback function or something like that. It can't just immediately return the value, or else it would have to be like a synchronous web request, and that would just like destroy everything. So what they did is kind of splintered off from the CommonJS group back in the early days and came up with the asynchronous module definition, or just AMD for short. And that is the type of module that RequireJS uses. So requirejs.org is where you get the stuff for RequireJS. The docs are out there. It takes a much more old school approach. So RequireJS has been around a lot longer than Browserify. You would actually go to the website and download require.js, the file name. Let's start looking at an example of that. So let me close all this stuff. And we'll start anew under require. So in my source folder, I downloaded jQuery because that's how you would have done things in the olden days. You would go download jQuery _ whatever else, and I put that in here. In my dist folder, I also downloaded RequireJS already. So there's an actual JS file that you need to plug in, unlike Browserify. And my index.html is basically exactly the same, except I put my script tag in the head here just to show how this gets set up, and that Browserify or RequireJS will wait until document load event happens before it actually initializes all of your modules. So you could put things, script tags in the head, and it wouldn't matter. And so the script tag for this one's a little bit weird. We actually start with the RequireJS file itself, and then there's a data-main attribute, and we have a path to what essentially would be our entry point module, which actually isn't a module at all. It's just a code file that's going to get run first on document load. So I currently have that pointing to /source/calc.js, which we're going to create in a moment. And then after RequireJS loads, it'll pick up whatever file was specified in data-main and load that and execute it. All right, so under source, let's start doing the same thing. So I'm going to make my operators folder again. Expand. Let's start with addition. And so the syntax here is different. So now we're using AMD syntax, asynchronous module definition. This has a function called define that we're going to call to, really? Thank you, Sublime. That we're going to call to set up and define our module. It's going to take 2 parameters. The first parameter is an array of other modules' names that this one will depend on. Addition imported nothing else. We had no other require statements back in the Browserify example, so this is just going to be an empty array. And then there's a callback function that would take an equal number of arguments as there would be in the array on the left side. So this is empty for now. It'll make more sense in the next module. And this callback function will be called by RequireJS when all of the modules that you said you depend on in this array are done loading. So it gives it a chance to say, hey, you need these 5 modules loaded. Cool, I'll go fire off 5 web requests, get all those files, bring them back, let them run, resolve any more dependencies up the chain that they need. Once they're all done and the dependency chain's been resolved, I'll call your callback function with all the modules that you wanted to load. And so this one doesn't have anything. And where common JS style modules had an exports object that we assigned everything to, in AMD we can just flat out return an object that we want to represent our module. So that is our addition module. It just returns an object that will represent this module. It has one function named add, takes left and right parameters, returns the sum. Depends on no other modules. That's about as simple as this one gets. There's no other magic where Browserify wrapped everything in a function for you, because in this one, you typed that function in. So there's a little more ceremony to this one. There's a little more boilerplate code, and that's a knock that people use against it all the time. They have to type more stuff. But it's also a little bit more explicit. You can really see what's going on. All right. So this one also gets a define function because it's going to be a module. It now needs addition. So where we used relative paths in common JS modules and in Browserify and Node.js, in RequireJS, all the loads are based off of a base URL that it sets up. And that base URL will be the first file that it loads from its data-main. So everything's going to be relative to this calc.js file by default. So /source from dist becomes our main URL that everything is loaded from. So that means to load the multiplication and addition modules, we need to go into operators / addition. And then this will call a callback function. And it's going to pass addition in as the first parameter. So we can give it a property to assign it to. These names don't have to match. They just usually do because that makes the most sense. And yes, thank you. I'm just going to steal my code from over here because it worked so well. And indent it to match. So that's there. There's a lot of nesting going on here right now, but again, this is in a function, so I could have said like var multiply equals function whatever up here if I wanted to, and then just kind of returned multiply, or returned an object that had multiply assigned in here. I didn't have to like nest this as an anonymous inline function here. But that's basically it for the multiplication module. So all the module loading is taken care of up here. I don't have to have an explicit require statement or anything. And then it just gets used down here. All right, so calc is going to do a lot of the same stuff that this one did. And again, because this worked so well, I'm just going to copy all this mostly over here as a baseline to save some time. So the require statements aren't what we want anymore. So those are going to have to change. So what we'll do instead is have our, okay, so this is the entry point to the application. So this isn't actually a module in RequireJS. It just becomes a JS file that's going to run as the first thing. And so it doesn't get a define because that would define that this is a module. Instead, we use a require function here to basically say, hey, I want you to go load a bunch of modules and then tell me when they're done. And I'm not going to be a module myself, but I need these modules right now. And it takes the same syntax as the define function. So we want operators / addition, even though we're not actually going to use it. And operators multiplication. And then there's a callback function that's going to get in addition and multiplication. And we're going to turn on word wrap so you can read it. So you can already see that this kind of gets long. If you have like 10 things you're going to import, this is going to be a pretty long line. And people will start to like add line breaks in interesting places to try to make it look nice. That goes to that. So this is a callback function. And the thing I'm missing is jQuery. So let's throw a jQuery up here in the front. And we'll assign jQuery to a $sign parameter so it plays nicely with what we already know. That can go in there, which hopefully fixes our code. OK. So jQuery now is specified here, and Browserify had resolved that with an npm installed copy of jQuery. This is kind of old school, so we have jQuery actually downloaded over here in a separate file. And its name is large jQuery-2.1.3.min. So this could be jQuery-2.1.3.min without the .js, and that would go and load jQuery correctly. But this name kind of sucks, and if we ever change versions of jQuery, we don't really want to go find and change these. So we can actually change this. Let's get rid of our comments now. So RequireJS is very configuration-centric. You'll notice that talking about Browserify, I did nothing to configure Browserify. It just worked with its rules, and that was it. And those are kind of the rules that you just use and follow, because that's what they did. With Require, it's much more flexible. So you can call require.config and pass in some settings object. And one of these is a thing called paths, and we can map paths to different things. So we can say, when somebody asks for the jQuery path, I actually want you to use jQuery-2.1.3.min. And so now when require needs to load the jQuery module, it's going to look at paths first. And we very well could have changed operators to be a different folder. So it would do partial matching too. If I added a path in here and said operators is now foo, then I could rename this folder on the left from operators to foo without changing my require statement in here, and it would still work. So as you refactor things, it's a little bit more flexible. And these can also be complete URLs. So I could have put like, some CDN in here and loaded this off the jQuery CDN if I wanted to.
Comma need to be colon?
Yes, thank you. Sorry. All right, so RequireJS ends up being configuration heavy in the end usually, especially as you bring in third-party tools. Things like underscore aren't really aware that they're in a module loading system like Require, so they just throw the underscore variable in global scope and call it a day. And there's a way to shim in like underscore into a module, so when you ask for a module named underscore, it would actually go pull window.underscore the variable and give it to you as a module and things like that. So if we run our browser here, hopefully this works. Okay, so this is still here. Did our code work? Oh, it works now. Thank you, person who told me it was in the wrong place. But look at our network tab. We actually individually loaded every one of these JS files. So what Require does is when you ask it for a module, it'll check its internal cache of modules that it's already loaded and say, do I have this? No? Okay, cool. Let's build it into a URL. Go hit the server and fetch it. So it really wants to do dynamic runtime module loading by default. So if you were in the last talk, he finished up with talking about how this is a very bad thing for performance. Super cool for development time, though, because it makes debugging super easy even without source maps. So you can go into every one of these individual files and set breakpoints. You see exactly what's getting loaded from where. But not the most efficient thing for runtime. And that is where, oh, sorry. So these are some basic module loading rules for RequireJS. They're loaded relative to the HTML document that's loading them, or depending on them. If you actually put a .js at the end, or it starts with the slash, or contains the HTTP, then it's not really relative. It's just going to load it from wherever the URL is. So you generally start your module names with a plain character and not a dot or a slash. Otherwise, it uses this whole concept of a base URL, which is the location of the main module, which in our case was calc.js, and basically builds up base URL plus module name plus .js. And you can use the paths configuration to override that if you need to. Okay, so not the most efficient thing at runtime yet, but that's where r.js comes in. So there's a separate file that is the RequireJS optimizer, and it's simply called r.js. This you can npm install or download off of their website. It is written in JavaScript and runs in Node.js at build time, a lot like Browserify does. So I have already installed that. And the command for r.js is really long. And if you've npm installed this, you would think that you can maybe just type r.js and run it. And sometimes that seems to work. Sometimes it actually opens up a JavaScript file in Notepad if you're on Windows. So I believe there's an r.js.cmd that you actually want. For some reason, Windows thinks r.js, like it actually has JavaScript files associated. So it's a little bit weird. But I think, good, this is already in here. I don't want to retype this anyway. All right, so there's an r.js command. We're specifying -o, which is for optimization. And then we're giving the main module name over here. So this would be the module name of the module that we want to be our entry point, which in this case is the calc module. And then we specifically give it a base URL to load things from, which is the source directory here. So we did that whole base URL plus method, or plus module name plus .js is where it'll go load the file from. Then we specify a main config file, which is also our calc.js file, because that's where we called RequireJS.config and gave it that paths config. And finally, we give it an out directory over here, which is dist/calculator.js, which is going to be the same file name that I did for Browserify. So we can do that. And this one actually gives helpful output. And you can also see that it uglified as one of its steps. So by default, it minifies things. And then it gave us each individual file that it went and pulled in with the full path on your hard drive of where it resolved that from. So when there's an error figuring out where a module is, you can actually get the full path here. Now back in our code, this is going to require a change to get Browserify out of the way. to our index.html, no longer will we include calculator.js or calc.js from the source directory. We'll just grab calculator.js, which is now hanging out over here and actually in the right place with our index.html file. So let's reload this guy again. And now in our network tab, you can see that we grabbed index.html, we grabbed RequireJS as a separate file still, and then we pulled in calculator.js, and that was it. And this still works amazingly. And so what happens here is that built-up file actually takes all those define functions and really just concatenates them all together into one big file. And then as it processes calculator.js, it calls all those define functions, which plugs in all those modules and associates them with their module name. So now when calc.js says, I need addition, I need multiplication, RequireJS looks in its internal cache of modules and says, oh, I already have these. They were in calculator.js, they're already defined. Cool, I don't need to go to the server and request them. If you're doing a large-scale single-page application, you can really use RequireJS to your benefit because you could make a bundled-up like app.js file or some kind of core file that contains all your core functionality that you want to load at application startup. And then maybe each of your individual page navigations, you could just not put in that file. And if you try to require them and RequireJS sees they're missing, it'll go and hit the server to load them. So you could rig it up in such a way, if you're clever enough, to make it load a bunch of core functionality up front, but keep that payload kind of lightweight and not bring in every single page's content in your entire single-page app. And then on first navigation to a page, you could actually hit the server to require in the data just for that view, which is a pretty handy optimization if you're trying to make your giant single-page app a little lighter weight to load. That takes a little bit more doing than this, but it is possible. So this would be the way to better optimize your runtime, a little bit more like Browserify. OK, so here's kind of a handy comparison table. Browserify definitely has less configuration, in fact, pretty much none, unless you associate some plugins with it. So if you're just looking for super simple, Browserify is usually the way to go. If you're comfortable with Node.js already or want to share modules between Node.js and your client tool, Browserify is a good way to go because you could load the exact same module in your server-side Node.js and your client-side JavaScript in the browser. They're the exact same syntax. RequireJS is a little bit more heavyweight, a little more boilerplate stuff, but a lot more flexible through its configuration. There's a ton of stuff you can set up. And since it does do processing at runtime, you can also have it dynamically load modules better. If you wanted to figure out what module to load based on a string, so like concatenate a couple strings together and say load this module by whatever name I just made up at runtime, you can't do that with Browserify because there's really nothing at runtime to go and do it. It needs to be a build time step. And there actually has to be a static string in there when it looks at your abstract syntax tree to figure out what modules to load. Whereas with RequireJS, it actually does runtime checking and figures out what module you passed in. So you could just pass in a string that you've concatenated together or done whatever dynamically at runtime. Otherwise, they both do source maps. They both have a rich ecosystem of plugins to modify the functionality and things like that. Personally, I've been a big RequireJS fan for a long time. That was the one I really started using and kind of stuck with for a while and really like using. But I'm also pretty lazy, and Browserify has a lot less typing to do. So that's kind of been my new go-to guy, especially if I'm doing a smaller scale application. And being able to just npm install jQuery, npm install underscore, and then reference them as modules right away is super handy. And I don't have to go find the website for whatever tool and download it. That's pretty much it for that. I am also a Pluralsight author, so if you want more information on either of these, I have a course on Browserify and a course on RequireJS. Each one is over an hour long, so longer than this talk. In those courses, I get a lot more into unit testing, because there's some unit testing nuances with both of these things, which we didn't really talk about, but you can mock out modules so that you can make small testable modules. So if you're doing this kind of stuff, I highly recommend unit testing your modules as well. If you don't have a Pluralsight subscription, I have some free 1-month subscription cards in my bag I can give you. You can come down and talk to me. Otherwise, that's it. I hope you guys enjoyed. Lunch is right after this. In fact, it's stacked up over here. So if you guys have questions, I'll let you guys get to lunch now, and I'm just going to hang out down here during lunch. So if you have questions, come and talk to me.